I can feel the physics.
If we're only given the starting and the ending angle, you use the omega number. That's actually cool.
So I asked them about 4
So
and
like,
Alright, we're
she
rolling.
said, she was like,
Are there any questions?
Dr. Fox, can you talk about how to use the angular speed again, like the omega equals 1, and how you're supposed to use it?
I think this will do it. 40-gram bomb attached to a 1.5 meter long string is swung in a horizontal circle. If the bomb takes 20 revolutions in 25 seconds, what is the angle the string makes with the horizontal? We assume it takes place on Earth.
So there's no, so it's being swung in a horizontal, so there's no angle. So from the, it's just a zero angle from.
The horizontal would be 0 angles,
Okay.
but it's, you know, really, it's going around in a circle like this.
All right.
So first step, draw the picture, if it's not already provided. That's what I'm trying to find. I have some mass in here, which I know is 40 grams, or mass is 0.04 kilograms. Sorry, my pause is I'm trying to figure out if I gave too much information or too little, but we'll figure it out as we go. All right, so we're trying to find theta. I know mass is traveling in a horizontal circle. And pretend that's horizontal. All right, like any of the other problems we do. facades. I could, now, it is traveling in a circle, I can pick any point that I want, but I find it easiest when doing the force diagram to pick an extreme, either the left-hand side or the right-hand side. If I did it when it is directly between sort of the middle post and cube, it's a lot harder to draw. So, what are the forces acting on the mass?
Tension and weight.
Okay. There's the force diagram. What is the direction of acceleration?
To the right.
Why?
Because that is the direction in the center of the circle, since that's centripetal.
Yes. Okay. Coordinate axes.
In the same direction as acceleration. And J hat, can we do J hat? Yeah, awesome.
Because Moore said so.
So acceleration is in the direction of the horizontal?
Yes.
Like exactly?
Yes. Because it's traveling in a horizontal circle. Something's traveling in a horizontal circle, there's acceleration based upon change in direction, and that would be pointing towards the center.
But it will be like this though. Like the acceleration, the direction of the acceleration would be not to the right exactly.
All right, so if I'm looking at an overhead view, so overhead, and I have something traveling in a circle. If it is traveling at a constant speed, the acceleration is based purely upon change in direction, and it's pointing towards the center of the circle. That's centripetal acceleration. If while it's traveling in the circle is changing speed as well, then you would have a centripetal component and you would have a tangential component. And so the net, so the actual acceleration would be the sum of those two. Now the intent, even though I didn't write it, the intent is that it was traveling at a constant speed, so that the only acceleration is because of change in direction, which is pointing towards the center of the circle. Did you follow up?
No, I think I'm thinking.
So let's see if we remember that. At a constant speed. Decomposition. Do we have to break either of them up?
FT.
All right. I know that theta is defined against the horizontal, so this angle here is theta. So I would have weight acting down. To the right, I have tension times the cosine of theta, and up I have the tension times the sine of theta. Now what?
You write our equations.
Okay. How many equations of motion will I have?
We will have two.
Okay.
So the first one will be, for I hat is going to be ft cosine theta equals m times centripetal acceleration. And second will be w minus ft sine theta equals 0, because it's not moving in the vertical direction.
Okay. Or more specifically, not accelerating. What comes after the equations of motion?
Substitution.
Yep. So for which of these do we have an independent formula?
For w, it's w equals mg.
All right, so I got mg equals ft sine theta.
And then for centripetal acceleration for the beginning, it's going to be v squared divided by r.
All right. We have two choices there. It's either going to be v squared over r or m omega squared r. Now, in this particular case, I know the length from here to here. That's 1.5 meters. I don't know that length. So, I don't know the speed. If we label this as r, which is what we have down there, what is the relationship between r and, we'll just use capital L for this. What's the relationship between r and capital L?
L equals R theta.
Say it again?
No, never mind.
L times cosine theta.
Yeah, so this is the triangle, this is the physical triangle we're looking at here. This angle here is theta, that's L, that's R. R is L cosine theta. So if I plug into the mv squared over r, because again, I'm trying to find the angle. I have ft cosine theta is equal to m v squared over L cosine theta. If I plug into the m omega squared r, I get ft cosine theta is equal to m omega squared L cosine theta. So it depends on how you want to solve it, but I know L, I know M, I don't know tension, I don't know theta. Omega I can find. Over here, I don't know the speed, I know L, I know M. So I've got tension, the angle, and the speed are all unknowns. Here, I have tension and theta is the unknown. So I have 3 unknowns there, I have 2 unknowns here. I do have another equation down there that the weight is equal to the tension times the sine of theta. What I'm trying to do is find theta. I know from that second equation down there, I have mg divided by the tension is equal to sine of theta. And on this equation here, yeah, theta is an unknown, but I have this cosine theta and cosine theta, those can cancel out.
So it's just
And what I'm left with here is that the tension is just m omega squared L, which I can pop into that. So I have mg over m omega squared L is equal to the sine of theta. M's cancel out. And it's just a matter of figuring out omega. Because your question originally was, when would you use omega squared, when would you use v squared over r? It really comes down to what you're given and what's going to look like the simplest math to do. If you did it this way, you would end up with a cosine squared. And if you got a sine squared by squaring that equation down there, you'll end up with a tension squared. It just becomes sort of a mess doing it that way.
So let's say, I don't know if this is gonna be part of the test, but I was watching a video where the question was saying like you were given a starting angle and then you're given an ending angle and then you have to find, I don't know what you're trying to find. I think what's the radius? So for that one, would we use like the omega symbol? If that's even part of the test at all?
That's what you're trying to find there. I gave you initial and final angle.
Mm-hmm.
They give you how much time it took to get from one to the other?
Yeah.
Okay, so omega is change in the angle over change in time.
Mm-hmm.
Well, in this particular case, I feel a need to finish this one. what is the angle it travels through? Dropping back, based upon this.
To find omega, do we have to use the 2 pi over divided by t? And then we have to divide this.
And t is just the period, that's how long it takes to go around once, which should be 1.25 seconds, or the flip of that, 0.8 seconds.
Yeah,
It was 20 revolutions in 25 seconds.
0.8.
Yeah.
I want period, I want the time per revolution
So T would be 25.
divided by 20. So this is 2 pi over 1.25 seconds. That's radians. You could have also done the angle to be 20 times 2 pi divided by 25. And whatever that is. Somewhere around 4 point something. So the angular speed of it is 4 pi radians per second. We can plug that into omega, solve for theta. Now, in the case of, if you're given the angle and time, you would just do the angle divided by time. The change in the angle officially. If you know how long it takes to go around completely, then you're, in essence, using the same equation, just the angle is 2 pi radians, and then the time is whatever the period is. I don't know if I've addressed your question or not.
It did, because I wasn't sure when we were supposed, because the only time that we actually used omega was when we were looking for the mass of the rubber stopper, but I didn't fully understand in what situations we would actually use omega.
Okay.
What,
Depends on what you're given. Yes,
what units would omega be in?
if you recall, we started with the arc length is equal to r theta, where theta is in radians.
Yes.
Doing the change over time, this becomes v is equal to r omega. That's meters per second. That is meters. So the units of omega would be the units of v divided by the units of r, which is a meter per second over meters, which would be
1 over seconds, so hertz.
Now, if you wrote down 1 over seconds as the units, it is not wrong,
Right.
but it's not as clear as it could be.
Seconds negative 1.
No, I mean, again, same thing. It usually is spoken of as radians per second
Okay.
as the unit. Now, radians is, I refer to sometimes as the unitless unit, because if we look back at this equation right here, looking at the units, I have meters is equal to the radius, which is in meters, times the angle, which is in radians. The only way it works is if radians is equal to 1. So, as a consequence, radians you can put in or take out whenever you feel like it. And I did have a student a number of years ago who just, after I did that, just tacked on radians at the end of all of his answers. Not technically wrong.
So we can write radians per second.
Yes, radians per second is traditionally the way omega, units of omega.
Okay.
Now, in everyday life, RPMs is also a unit of omega, just not SI standard.
So how is it that both of them are right though?
That 1 over seconds and radians over seconds?
Yeah. If I just wrote 1 over seconds, that would be right too.
Yes. Yeah, radians is a funky unit in the fact that since a radian is equal to 1, it really is not a unit per se. Typically, you put radians in there when it makes it clear what you're talking about. If I said that the angle was 5, technically, if I just left it at that, it's 5 radians. But if I don't put radians down there, the question might come into the person's head of, did they just forget to put degrees down? Did they leave the unit blank, or did they deliberately leave it blank? And so you put radians in just to clarify.
So if you were putting, let's say, the 5 radians in the calculator, how would we just put just 5?
Wait, sorry, ask that again?
If you're putting 5 radians into the calculator, what would we just put, just 5?
Well, I mean, you'd be in radian, you would set your calculator to handle radians, and then when you typed in 5, just like with angle and degrees, you don't actually use the degree symbol on your calculator, I
Alright.
assume.
Yeah.
So this would just be what we just solved for would just be the angular momentum of the.
Angular momentum, shoot ahead. We've not found angular momentum,
Where is my brain?
not sure. I'm assuming right there, but
Who knows?
if you're doing astral projection right now, then
Probably.
who knows where it is. Yes,
So there's a test tomorrow. When are the other tests going to be?
after that.
But
And
there's
before
only
the 10th.
1 week left, so I want to know how.
Alright, what I'm sort of picturing is that the 9th is the last calculator test, and then the 10th would be the multiple choice test. That's what I'm picturing.
Wait,
So-
we have,
Well, we won't have another test in between tomorrow and the 9th.
Right.
Why? Why won't, can we have, cause we need to cover the material?
Like, what?
Cause we need to cover the material that's gonna be on the last 2 tests?
Well, we cover the material actually, that's gonna be on the multiple choice test.
Can we,
no, what?
Okay.
That multiple choice test, you took the first day.
So there's only
Unless you
one
weren't
other
here that
test
day.
besides the multiple choice test
Yes.
that we have to do after after tomorrow.
Yes. We got the test that's gonna start with energy, then momentum, and then whatever else we get to. That, and then that multiple choice test that you took. the
so on
first day.
9th and 10th?
Yeah, that's what I'm picturing right now.
And the 10th isn't gonna, the 10th is an hour and 20 minutes.
Well, it's the same multiple choice test
Yeah.
that we were given on the very first day.
Right.
Did